Greetings from Universal Engineering College and welcome everyone to the 6th International Webinar on Novel Trend Lines in Technology and Job Prospects, hosted by Universal Engineering College, organized by the Department of Electronics and Communication Engineering. My name is Chelsea Joy and I am the Assistant Professor from the Department of Electronics and Communication Engineering, Universal Engineering College, affiliated to APJ Abdul Kalam Technology webinar. My name is College, affiliated to APJ Abdul Kalam by a group of successful industrialists and business personalities to contribute back to the society and its development, realizing that only education can transform the society for a better living. Universal Family welcomes you all for the explosion of the knowledge with the speakers around the globe. Now, it's my privilege to call upon Ms. Ramya VR, the HOD, Department of Electrical and Electronics Engineering, for the welcome speech. Ma'am, please.
Thank you, Chelsea, for your brief introduction. Good afternoon, everyone. So, as she introduced myself, Remia Via, I'm the charge of the AAA department in my college. First of all, let me express my sincere gratitude for allowing me to welcome you all to this wonderful session. As we know, these are desperate times for the whole human race. The world is in the process of digitalizing every field, and with the limitations, we are rooting forward with these kinds of knowledgeable programs. Thanks to those enlightened minds for their contributions for making this a success. And without further ado, let me welcome our speaker of the day, Dr. Vishnu Vinayamohanan. Dr. Vishnu is presently with the Grid Performance and Integration Department in Australia. We are honored to have such a eminent and resourceful speaker for the first day. We are hoping to have a great time with the dear audience. Once again, thank you everyone.
Yeah, thanks for the warm welcome. So can I start?
Sorry, sir, some technical issues. Sir, a small inaugural is there.
Yep.
Now it's my privilege to invite Dr. Josuke Jacob, Principal, Universal Engineering College, to address the gathering. Sir, please.
Thank you, Chelsea. Warm good afternoon, all. Good afternoon, Dr. Vishnu.
Good afternoon. Thank you.
So, as we know, all of us are in a pandemic situation, and actually, we are utilizing this situation. We are taking the opportunities of this situation. So, that the best example is this platform, the Zoom platform. Mr. Vishnu is from Australia. We are from Kerala in India, and some other participants are from the various different countries are also attending this webinar. I'm sure that you'll get more information. You can grab more knowledge, and you can this information will uplift your present situation or uplift you from the present position. And I wish all success to this program. And I express my sincere thanks to Dr. Vishnu for your valuable time with us.
Yeah.
Thank you. Thank you very much.
Thank you.
Thank you, sir. And today we have our speaker, Dr. Vishnu Vinayamohanan, who gained his PhD in electrical engineering from the University of Melbourne in year 2019 on the topic the impact of inverter-based systems on power grid and power grid stability, and masters in mission drives and power electronics. from IIT Kanpur in the year 2013. Dr. Vishnu is currently with the Grid Performance and Integration Department of the Australian Energy Market Operator, AEMO, providing his expertise on assessing the system strength requirements of the Australian power system. Prior to the joining of AEMO, Dr. Vishnu was a power system consultant with Worley Persons in Australia in the year 2019 to 2020, where he has been an integral part of the power team focusing on the grid integration study of renewable and distributed energy sources into the Australian network. He has also worked as a casual lecturer at the University of Melbourne in the year 2016 and was responsible for delivering the electric power system course. Before relocating to Australia, he worked as a power system engineer during the year 2013 to 2015 with Power System Operation Corporation Limited, which is on subsidiary of Power Grid Corporation of India Limited. He was involved in the operation and grid management of the Western Regional Grid of India. Before getting started, we have just a little housekeeping. As you all know, please kindly mute your audios and turn off your videos for better bandwidth and far less streaming. And a feedback and an attendance link will be posted in the chat box at the end of the session and also in the chat box of YouTube live stream. Again, to a note, Kerala is having a quite stormy weather at this moment, and we cannot be so sure about connectivity and weather will permit us to give a perfect live stream. So if we run out into troubles, please cooperate with us and any inconvenience caused will be answered by us. Please don't try to attempt the share screen option at any point of the time during the presentation to avoid unnecessary confusions. And if you have any questions during the presentation, please type them in the question box or in the chat box in the Zoom control panel, and I'll bring them up during the presentation, and we will have a time for QA at the end. And now, without further ado, let me turn the time over to the speaker, Dr. Vishnu Vinayamohanan. Sir, please.
Yeah, thanks for the warm welcome, Dr. Jose Jacob and Professor Ramya. So I would like to thank Universal College for giving me this opportunity. I really appreciate that. And I would also like to specifically thank Associate Professor Srinath Madanan, who told me about this opportunity and I got excited about that. So I will share my screen to start with. Is the screen visible to everyone?
Yes, sir.
All right, thanks very much. So my topic today for the talk is recent trends in power systems and career opportunities. So I'll be talking a bit about some of the recent trends that is happening in power systems across the world, and specifically in Australia, and some of the career opportunities that students after their graduation can look for in power system sector as well as in electrical engineering sector. So before moving forward, I would like to clarify one thing, that whatever things that I'm sharing today here is my personal opinion, and it has nothing to do with my organization that I'm currently working or has worked. So just as a disclaimer, so this is the agenda for today's talk. So probably I will be talking about the recent trends in power systems and the challenges that are involved in the transition phases in power systems and the solutions that our industry providing to these challenges in the first 15 to 20 minutes. And afterwards, I'll be talking a bit about some of the career opportunities that students can look for in the power system domain, as well as some of the essential tools that students can learn, which can help them get ahead of the queue when applying for a job. So here in this particular section, I'll be demonstrating a bit about Python language, and will show how the Python language is so important in getting a job in power system or other electrical engineering domain. And finally, there is a Q&A session for, let's say, 5 to 10 minutes towards the end. So if anyone wants to ask any question, you can obviously jump on and interrupt me anytime if you want. I appreciate and encourage you to ask questions, and if at all you can't, if you want to keep that towards the end, I'm happy to answer the questions at the end. So let's start. So um, so basically, I'm going to talk a bit about the evolution of power systems over the past decade. So the changes that are happening in the power systems, and why the changes are happening, and what are the challenges involved at present in the industry, and how industry is overcoming those challenges. So basically, I'll be providing a high-level overview of this topic. I won't be going into too technical stuff. Yeah, so I think we can start. So here, we know that the conventional power system network has a centralized structure, meaning that all the generating stations will be located in a centralized locations, and the power generated from these generating stations will be transmitted through transmission line network or transmission network towards the load center, and it will be distributed towards each of the load points. So this is the basic structure of a conventional power systems, and the transmission voltage will be like high voltage transmission. Basically, in India, I think the transmission voltage level is 220 kV to 765 kV, and in Australia, I think it is 400, 220, and 500 kV networks. So in the conventional network, the generating stations are predominantly thermal-based stations, meaning that the fuel source that are used for generating electricity are either coal-based or gas-based. So these stations are coal-based or gas-based stations. So in the world, around 80% of the total generation are coming from thermal generators. And all these generators will be located remotely close to their fuel reserves. For example, in India, if you look at this particular map here, this is a map from NTPC, which is the National Thermal Power Corporation of India. Most of the thermal generators are located in the northeastern side of India, where the coal reserves are abundant. So it makes sense to construct the thermal stations close to the fuel reserves, and instead of constructing the plants somewhere like if it is in Kerala, we have to transport all the coals towards the south. So so the basic structure is a centralized structure, and the reason for that is the abundance of the construction of the stations near the fuel reserves. And in particular in Australia, around 82.9 or around 83% of total electricity is produced by thermal based generators. So this is the general structure of a conventional power systems, and these type of systems are working fine and are reliable and stable, and it's working fine. Apart from a handful of events that happen in India, for example, I think in 2011, there was an incident happened which resulted in a partial blackout of the grid, where the northern and western side of India got blacked out. Apart from that, most of the time, the power system network are reliable. But recently, let's say in the past 5 to 10 years, there has been a significant increase in the amount of renewable resources. For example, solar PV, wind energy systems that are getting penetrated into the network. So in today's network, there is like a large number of wind and solar farms are incorporated in the network. So basically, we are changing the basic structure of the power systems in the past few years. So why we are doing that if everything is working fine? So the main reason for that is climate change. So we know that we are facing serious climate change issues in terms of global warming and other problems. So the main cause for these climate change issues are the emission of greenhouse gases into the atmosphere, and thermal-based stations account for a major chunk of this greenhouse gas production globally. So sorry, in order to get rid of this greenhouse gas emission from the power sector, at least we need to replace these thermal stations with some green energy sources. And apart from that, the green I mean the fuel sources like coal and gas are not sustainable, so eventually they will deplete, and we need to find an alternate source of energy. So that's the main reason we are trying to incorporate PV and wind energy system which are environmentally clean and sustainable. And this is the main motivation for us to change the structure of the network. Now, apart from that, there are like a bunch of factors which also contribute to the large scale acceleration of the incorporation of renewable sources into the power system network. The first one is the government policies and the renewable energy target, in short called RET. So in government policies, we see that we know that governments of various countries are promoting the green sources by providing incentives. For example, in Kerala, I think the KCV is providing incentive to install rooftop PVs in our home. Similarly, in most of the country, including Australia, governments are supporting the renewable projects by providing incentives. Apart from that, for a utility scale system, the Australian government in particular is setting a renewable energy target of around 25% by the end of 2020. The meaning of this statement is that Australia is trying to achieve around 25% of their total electricity production from renewable based sources by the end of 2020. Similarly, European Council aims for 27% by the end of 2030. However, some countries like UK, Germany, and I think Denmark, they have crossed this mark already. And in India, I think the aim is to install around 175 gigawatt of renewable sources into the network. So if you check the total installed capacity in India from the Power Ministry website, we can see that the total installed capacity at present is around 371 gigawatts. So if 175 gigawatt is roughly half the total installed capacity. So this is a massive amount that government is promoting to increase the penetration of renewable sources. So we can see that the trend is visible in all parts of the world. Apart from these government policies, the other important factors which affects or accelerates the penetration is renewable, technological advancements and economic factors. We know that the battery technology has advanced significantly over the past 10 years, and we can now see utility scale batteries that is being installed in multiple power systems across the world. In Australia, there are a bunch of battery projects that are installed for frequency control services. And apart from that, the inverter technology is also matured enough and are robust for utility scale operation. In addition to that, the economic factors plays also a major role in the incorporation, in accelerating the renewable growth in the power sectors. For example, the statistics shows that around 85% of the PV module cost dropped over the course of 10 years, and utility scale PV project cost dropped by 65%. So all these figures shows that there is a positive trend in the power system industry towards the renewable plants. And this is visible from these two graphs. In particular, this graph shows the installed capacity of wind, the global installed capacity of wind over the course of 10 years. So here you can see that in 2007, the total global installed capacity was 100 gigawatts, but in 2017, it rose to around 550. That's a massive increase. And similarly for PV, in 2007, the installed capacity was nearly zero, and it has an exponential growth towards 400 over the course of 10 years. So that is one of the major trend that is happening in the power industry. So it's happening all around the world in all power systems, in India, in Australia, in the rest of the world. this trend is quite visible. So it is reasonable to assume that the future grid will look like something similar to this. For example, there will be like a domination of renewable energy sources in the future network, with replacing all of the existing synchronous machines, all the thermal base stations by the equivalent amount of solar and PV sources. Also, there will be battery technologies installed in the system to support various operational scenarios. This change in structure is really good because we are getting rid of the greenhouse gas emission, and we are reducing the climate change problems that is being produced by the power system industry. So this is really good, but there are few catches or few challenges involved in this transition phase. So I will talk a bit about some of the challenges that we are facing in the industry at the moment. So basically, the conventional system is designed for synchronous machines. So synchronous machines, I'll just show a image here. So synchronous machine is something like this. This is an example image. It's a huge machine, weighing tons of kilograms. And so all these machines will be rotating quite fast. For example, the RPM or rotation per minute of each of these machine will be 1500 to 3000. These machines will store huge amount of kinetic energy in their rotors. So they have inertia, and this kinetic energy is crucial in maintaining the stability of the system. For example, let's say we have a power system in which, let's say we have 100 megawatts of load and 100 megawatts of generation. And suddenly when we lose, let's say 20 megawatts of generation, so ultimately we have 100 megawatts of load and 80 megawatts of generation. So there is a load generation imbalance happen due to some problems, and this will cause frequency of the system to deviate from its nominal value of 50 hertz in Australia and India, and 50 hertz, and if it's in US it is 60 hertz. So whenever there is a load generation imbalance, the frequency will deviate from its nominal value. And during this deviation in the frequency, the kinetic energy stored in the synchronous machines will be released to arrest this frequency deviation. So if we have a system which have a large number of synchronous machine, then the drop in the frequency during any contingencies will be minimum, because the synchronous machines will try to minimize those deviation by releasing its stored kinetic energy. So what will happen when we replace all of these synchronous generators with some PV source? So we know that photovoltaic or PV source are like a static element. It's not like a rotating machine. It sits simply idly, and it won't store any kinetic energy in it. So when we replace all the synchronous generators from the network, we are basically losing inertia of the system. And so when we lose a certain amount of inertia, the system will show serious problems in terms of frequency stability. So this is visible in the Australian power system network at the moment, and the industry people are trying various techniques to overcome these challenges. The other important factor that is associated with this the transition of the power systems are the reduction in system strength. So basically what system strength means that it's the amount of fault current that is available in any particular point of the network. For example, if we have a big system, or let's say we have the Indian power system, and if we take a particular substation, for example, we choose, let's say, Mumbai, and we have a substation in Mumbai, and if the fault level, let's say we have a certain amount of fault level, and if we replace all the synchronous generators from the network, specifically if we replace synchronous machines that are closer to Mumbai substation, the fault level in that particular area will reduce. The reason for that is that synchronous generators are designed in such a way that it can generate almost 200% of its rated current. That means it can supply twice its rated current if there is any fault happen in the system. So the advantage of this is that whenever there is a fault happened in the system, the voltage of the system will drop, and when the fault is cleared, the voltage will recover back, and the rate of this recovery will depend on the system strength in that particular point of the network. So if the system strength is quite high, the voltage recovery will be much faster, and the voltage stability will be higher in that network. So if we replace synchronous machines with PV and wind sources, these sources are typically power electronic based sources. So the amount of current that can be supplied using these power electronic switches are very limited, and it cannot obviously give a 200% leverage. It can maximum go up to 1.2 or 1.3 times of its rated current. So basically, if we replace a 500 megawatt generator from a system with a 500 megawatt PV, we are losing a significant amount of inertia from the network and significant amount of system strength. So this will cause frequency stability in the network, and this will cause voltage stability in the network. So these problems are very real, and it's really like industry is really struggling to overcome these problems by using various techniques. So in the next slide, I will show some of the techniques that that are being used or being considered for these kind of problems. So the first one is, like I mentioned here, that when we replace synchronous machine, we lose inertia from the network. So to overcome that challenge, what industry is doing is that they are providing synthetic inertia from batteries and flywheels. So what battery will do is that like a utility scale battery will be installed in any particular point of the network. So any location is fine because it's addressing the frequency. So the battery, what they will do is that whenever there is a load generation imbalance, like I explained previously, the battery will sense that deviation in frequency and try to negate by injecting or absorbing the active power from the network. So for example, if we lose 30 megawatts or 100 megawatts from the network, and if the battery is capable of supplying that much amount of power, it will supply that much power by sensing the frequency. And so that will happen really faster, and it will act as an inertia. So it's like the synchronous machine releasing its kinetic energy. The battery is injecting power quickly to avoid any frequency issues. Similarly, flywheels are like huge rotating masses, so it stores the inertia and it will work in a similar fashion. So the battery, utility scale battery, are being installed in many of the power system network. So I have provided an example here. For this particular project is called Hornsdale Battery Energy Storage System. So it's in South Australia. So you can see that these blocks are all batteries made by Tesla. So these are Tesla battery packs, and the capacity of this battery is 100 megawatts, and it's specifically using for providing essential grid support service. That means it is not using for generation or any other activity. It is specifically using for providing essential grid support service, meaning that it will act as a frequency control ancillary service. Similarly, there is another project installed in Australia, which is called Ganawara BESS. So it's similar, like we can see multiple battery packs installed and it is connected to the network. So I think you can also see solar farms here. So these are solar farms, how the solar farms look like and how the battery packs will look like on a utility scale. The other important aspect that industry is trying is virtual synchronous machine. So I'm not going to explain the details of virtual machine, but I'll try to give you an overview. So virtual machines are basically inverters and solar PV or wind generators, but the inverters are designed in such a way that it will imitate the behavior of a synchronous machine. So from the grid perspective, if we look at a virtual machine, we see that it's similar, it behaves similar to a synchronous machine. So what basically the control system of the virtual machine is doing, that it is emulating the dynamics of a synchronous machine, and it will create a similar response. So these are some of the recent trends that is happening in the power system. I'm sorry. Hello, can you hear me? Okay, all right. I will continue. In a nutshell, what I can say in power system sector is that the power system structure is changing due to the incorporation of renewable sources like solar, PVs, and wind and batteries into the system. So it's basically changing the centralized structure into a distributed structure. And due to these changes, the grid is experiencing serious problems, including like the frequency stability issues, a reduction in inertia, reduction in system strength, and some of the techniques that industry are trying to are using now is by using battery to provide synthetic inertia, and as well as flywheel to create inertia. And another one is synchronous condenser. I think I missed to explain this one. So synchronous condenser is essentially a synchronous generator. It is not like a synchronous generator, but it's a synchronous machine without a prime mover. So it will rotate freely, and it will generate reactive power. So since it is a rotating machine, it will store kinetic energy in it. So it has essentially has an inertia in it. And since it is a synchronous machine, it can provide or improve the fault level in the network. So this is also widely considered in Australian network. So I personally know like a bunch of projects, wind farm projects, where synchronous condensers are being installed to improve the fault level in the system. So these are some of the recent trends that is happening in the power system across the world. So if anyone have any question, feel free to jump on now. I'm happy to answer. Or if I'm going too fast or too slow, please let me know. Any comments? Welcome. Yeah, so if you don't have any comments, then I'll probably jump on to the career opportunities. So yeah, sorry.
Hello, sir.
Yep.
There is no questions right now, sir. I think you can go for the next topic.
Yeah, sure. Thanks for that. My next topic is career opportunities. So in this section, I will talk a bit about how to prepare your resume and LinkedIn. I mean, update your LinkedIn profile, and I will also talk about a bit about what are the job opportunities that people can look for in specifically in power system domains and in general in electrical engineering, and how this job like how does this jobs will feel like if you get an opportunity to work on those areas. And I will also explain a bit about some of the tools that are essential or necessary to get a job or to perform well in a job if you get one. So I will talk a bit about some of the tools towards the end. So in this section, I'll be talking a bit about resume and LinkedIn. So to start with, I probably you might have heard about ATS. So ATS is called Applicant Tracking System. It's a software used by like it's currently using by many of the multinational companies and recruitment agencies. So what basically this software do is that they will screen your CV. Like if you apply for a job, it will scan your resume and select certain resume based on certain criteria. So for example, if any particular company advertised a role online, and let's say 2,000 people applied for the job, so it will be difficult for the HR personnel or any recruitment agency or any recruiter to go through all the 2,000 CVs individually. It's not productive, and it's time consuming, and that's not the way the people in the big industries are screening or selecting their candidates. So what they typically do is they upload all your resume into a software called Applicant Tracking System. So this software will screen your CVs. So what specifically they do is they check for any mistakes in the CV. So like it's highly likely that if you have made a lot of mistakes in the CV, then the ATS will highly likely reject your CV. And let's say, for example, the role you are applying is for a software developer, and they specifically ask for candidates who know, for example, Java, JavaScript, C++, or HTML, CSS. Let's say these kind of tools they have specifically asked for. So ATS will look for the look in the resume for these type of skill sets. For if any candidate have these skill set, they will probably choose those candidates, and those who don't mention anything about this in their resume will be rejected. It's highly likely that ATS will reject their resume. So it's so what I'm stressing here is that if you are applying for a job, look for the criteria and look for the skill set they are asking for. And if you have the relevant skill, try to include that in the CV. And if you only know a little bit about those tools or software, and just add that. That is my recommendation. For example, if you know a little bit about Java, then add that. You can always learn later. So that's my advice. And the other important point I would like to stress here is that try to make the resume as concise as possible and compact. I've seen that like in some CVs, people try to, especially those who are recently graduated, they make the CV like 5 or 6 pages long. So it is not advisable to keep the CV that long. Like people are not so interested into reading a long CV. So mainly if you can limit the CV to a maximum of 2 pages or 1 page, it would be like highly recommended. So in my case, I personally use a 1 single page CV. And I think if you can keep it to a maximum of 2, it would be advantageous when you're applying for a job. And the next, and it's like, it's my personal opinion though. And if anyone is having like a lot of experience, they can definitely go for a larger number of pages. And I have put some example CVs here, which will give you an overview of. So if you can see this one. Yeah, so these are 2 CV I just randomly downloaded from the internet. So if you can check this one, for example, this particular person has mentioned all his work experience, education and skills, and profile, everything, and awards, everything in a single page. So I think this type of formatting is really important if you are applying for like a job where the number of applicants are huge. For example, if there is a company are getting 2,000 or 3,000 applications, and if you are writing a 6-page CV, they will probably reject you. They don't even look into your CV. So this type of formatting is like if you can make one, it will be helpful. I think that's my personal opinion. And the other important thing that students can look for is their LinkedIn profile. So probably you might be knowing the importance of LinkedIn already, especially in Western countries. When you apply for a job, they always ask for a LinkedIn profile, the link to the LinkedIn profile. So it's really important that you keep your LinkedIn profile updated. And if you have like any relevant skills, you can always add that into the profile. And I think in India, the relevance of LinkedIn is also getting higher and higher. So in future, I can definitely say that LinkedIn will play a significant role in applying for jobs and for the recruitment agencies. So it's highly important that students or any recent graduates needs to update their LinkedIn profile and add all the relevant skills. So you can also add any certifications that you have done that is relevant to the job or any job. And LinkedIn also have the search option for searching different job opportunities. I personally searched today for power system jobs in India, so there are a bunch of opportunities popping up. So it shows that the companies are advertising in LinkedIn as well. So you can try for that. And another thing that students can look for is the LinkedIn Learning. Probably you might be knowing this thing. So if anyone is not sure about LinkedIn Learning, you can go to your LinkedIn profile, and at the top there is a tab which shows LinkedIn Learning, where you can uh, access different courses. For example, this one is actually not my profile. I haven't signed in, but if you signed in, you can see a tab at the top right corner. So for example, here you can see like software development courses are there, then data science courses are there. All these courses are like short courses, maybe like 2 hour or 3 hour courses. So it's not like not so time consuming, but you will get a high level overview and sometimes more specific details about different things from these courses. And once you finish the course, you can get a certification from LinkedIn, which you can add into your profile as well. So I think these kind of courses will help you in the long run. You can update your LinkedIn profile, and you will also learn very like different skill sets, and that will help you to get jobs or help you evolve in the job. So these are my some of my recommendations when you prepare your resume and LinkedIn profile. So in short, try to keep your resume as short as possible, as concise as possible, as compact as possible, and try to involve the keywords that are relevant to the job. So if you are applying for multiple jobs, look for the keywords, just add that into your CV if you know a little bit about those skills. Um, so that's one of my advice in this area. Now I think we can move on to the jobs that are applicable to power system domain. So specifically, like in power system domain, there are a bunch of opportunities called grid connection engineer, then power systems engineer, then solar and wind engineer. So these are some of the recent opportunities that are keep on popping up in the recruitment websites that I have seen. So so in grid connection engineer, what is a grid connection engineer means, what are their responsibilities means. The main responsibility is to facilitate grid connection studies. So what this means is that, for example, if I have a solar farm constructed, let's say I constructed a solar farm in Cochin, and I wanted to connect that to the power network in India. So to do that, I need to get approval from the relevant authorities. So the authority will give the approval only if I can showcase them that my system is stable, reliable, and it won't cause any trouble in the system when I connect that to the network. So when I construct a 100 megawatt solar farm and I connect to the network, I need to show them that it will work fine, it is stable, it is reliable, and it will not interact or impact any other system components in the network. So what I will do is I will contact a grid connection engineer in a consultancy and pass on my mathematical model of the solar farm. So I will pass them either a PSSE or a PSCAD model, which is a mathematical representation of my solar farm, to the grid connection engineer. And what they will do is they take the model and do some simulation studies in certain softwares to assess those criteria. Let's say, for example, I wanted to test my solar farm if it will work when the voltage in that particular point of the network will rise. So I will apply a higher voltage in the simulation at the connection point and check if my solar farm is working fine for that particular incident. Similarly, there are like a bunch of criteria that I need to test the performance of solar farm against. So these kind of studies will be done by grid connection engineers. So I think it's really interesting if you like technical aspects of power systems. So this grid connection engineer role will involve high amount of technical studies, and it also involves let's say management opportunities. So you need to interact with clients and the government agencies. So it will develop your management skill as well. So this is one role that you can look for which is like involve a lot of technical studies as well as management skills required for this role. And another specific role in power system domain is power systems engineer. So basically, in power system engineer, there are multiple options available. So the first one is a power system operator. So power system operator, what they do is usually they work in control rooms, in the load dispatch centers, in different parts of the control. For example, in India, we have like 5 regional dispatch centers, one in Mumbai, Delhi, then Calcutta, then Bangalore, and I think one is in Shillong. So there are 5 load dispatch centers in India. So what the operators will do is they will monitor the performance of the grid. They will monitor the voltage of the network, frequency of the network, and the flow, the line flows, and all those stuff. And if anything is going wrong, or if anything is violating, for example, let's say in any part of the network the voltage is rising, then they need to take necessary action to control the voltage in that part of the network. Or if the frequency of the system is deviating from the like the nominal value, then they need to control the load generation so as to bring back the frequency to its normal range. So these type of roles will be performed by power system operator. I personally worked as an operator for 2 years in when I worked in Power Grid Corporation. So it's a like 24/7 job. So you need to work in shifts. So if anyone is not interested in shift jobs, then it is not recommended. But once you get the opportunity to work in that company, you can definitely switch the department after a few years. And another role a power system engineer will be involved is the analysis role. So in this particular role, what engineers will do is like they will carry out studies to identify like any possible problems that could arise in the network. Let's say, for example, there is a maintenance that is going to happen in the network, and the next day, so when we take that line out, what will happen to the system? So those kind of studies will be conducted by power systems engineers. So they will use various simulation tools to analyze the performance of the system for various events. So that is interesting role. So these both roles are highly technical, and like there are like management roles as well involved in the like a power system engineer can also work as a project engineer or a similar kind of role where management skills will be needed. The other type of role that I came across is solar and wind engineer. So specifically, the engineers will work in development of models, solar and wind farm models, and simulation studies, and also the commissioning work. So for example, in the previous example that I mentioned, if I wanted to connect a solar farm to the network, there will be like solar or a wind engineer in my team. So they will develop the model, or they will like consult with other agencies to develop the model, and they will carry on the simulation work and also carry out the commissioning work of the solar farm. So all these kind of roles are like some of the roles that I can think of specifically in power system domain. And apart from that, in a general sense, electrical engineers in India can definitely apply for public sector undertaking jobs, then Indian engineering service jobs, then government jobs. And so I have just provided a link here which shows the list of like the public sector companies in India. So there are like a few companies in India where you can get a job, but it may not be a power system role, but it will be definitely an electrical engineering role. I think most of you know like how to get a job in PSU. You need to write a gate exam, and once you land in a good rank, they will probably invite you for the interview, and you can get into any of these companies. Next one is a private undertaking. So this includes like multinational giants like ABB, then Siemens, then Bosch, and Reliance, Adani, and there are so many consultancy companies like Worley Parsons, then Jacobs. So in this type of companies, and the role will be like different type of roles are available. You can work in technical sector, management sector, project engineering sector. So so the different roles are available for electrical engineers in these companies. And apart from that, the next option is research. So if anyone is interested to continue studies after their bachelor's or master's, they can definitely join a PhD course overseas or in India, and they can continue their research. And once they finish the research, they can definitely go back to the industry or academics. Personally, I finished my research last year and joined industry rather than going to academics. So there is a general thought that once you finish your research, probably you will need to go to academics, but that's not the case. There is definitely options available to you. So you can join in industry as a researcher, or you can go to academics if you are interested in teaching. Uh, and obviously the last one is startups, but I'm far from the expert, so I'm not in a good position to explain about startups. But if you have a groundbreaking idea, you can definitely try that. Uh, Now, what to expect from these in these sectors? So like I will give a brief overview of like how the jobs in these sectors will look like. I personally worked in a PSU, a private company, and I did some research, and I worked in academics for 6 months. So I think I can give you a feel how these jobs will look like. So in specifically in PSU, I would say the most attractive factor for joining a PSU is this job security. So I think that is quite relevant in the current COVID situation, where so many people are losing their jobs. So PSU jobs are like permanent jobs. You won't lose it unless you end up in a criminal case. So otherwise you won't lose the job. So it's highly secure. And the job, in terms of the job roles, it may not be too technical in my opinion. There won't be much designing stuff involved in that, but there is like little bit of technical stuff will be there, and non-technical jobs will be there, but it's not like too technical. And another important thing about PSU is that it provides a medical facility for your dependents. So if at all, if you are in a need of any, or if you are in a medical situation, these PSUs will cover your medical cost. But private sectors, I don't think they will give enough medical support compared to the PSUs. But and also in terms of job security, probably private companies are less secure than PSUs, I would say. But in terms of the job, the opportunities will be like more, like if you want to go into too technical stuff, and there will be like research wings in many of the companies. For example, in ABB and Siemens, they have like R&D department where they conduct serious research to develop actual systems. So if you are interested in that, you can definitely look for that. And jobs, you can get wide variety of jobs in private sectors. And another important thing of joining a research field is that you will get a deeper understanding of topics, various topics. For example, so if you are working in a power systems research area, then you can work in different areas like stability, power system stability, then power system protection. So you will become an expert in those areas after doing 4 or 5 years of research. That can also be achieved if you are working in an R&D department in a private company. So these are some of the benefits of joining in a research field. You will get a confidence to learn things by your own. So self-learning is an important aspect of research. So you will need to learn so many things by your own. So you will become capable of doing things or researching stuff once you finish your PhD. And in terms of academics, I think in my personal opinion, it's a bit more flexible compared to private jobs. But others may disagree with me, but that's my personal opinion, and you will get the opportunity to involve in research activities as well, and also to mentor students. So these are, I think, some of the benefits of different organizations. Like um now I think I will just give you an overview of some of the tools that are specifically applicable in power system sector, and how you can, like if you know these tools, or if you have an understanding of these tools, that will help you to land in a job, especially in the power system sector. And specifically, I'm going to focus about Python today. So Python is a high-level programming language. It's an open source language, but the relevance of Python is increasing day by day. So in a power system industry, if you are working, it's highly important that you know Python. For example, in my day-to-day work, I am mostly using Python every day for interfacing them with PSCAD and PSSC softwares. So I have provided a link in this presentation, so that if anyone is unaware of Python, or if anyone would like to download Python, you can obviously search in Google for Python, and you can install that. And if you specifically wanted to work in let's say in a Spider or any other Jupyter notebook environment, then you can download Anaconda versions. So all operating system versions are available, so you can download that and play around with that. So I will talk a little bit about Python today. So before going to that, uh, what are these tools, or like how these tools will work, I will give you a bit of overview about those stuff. So basically, all these softwares, for example, PSSE, ETAP, Dixilent, and PSCAD, MATLAB, all these softwares are used to solve various problems that are present in real world system. So specifically, this PSCAD and PSSE softwares are used to solve power system problems, and to identify like if there is an issue will happen, or like for example, if you want to construct a new transmission line, how the new transmission line will perform when we install that in the actual system. So these kind of studies can be done using softwares. So I will give you a brief overview how these softwares work. So basically what these softwares will do is that they will represent all the components, physical components, as a mathematical equation, and they will try to solve all the dynamical equations numerically. So they will use, these softwares will use numerical methods to solve the dynamic differential equations, uh, to predict the trajectory of the different variables. So I think that most of the final years electrical students might be knowing about these methods. For example, Gauss-Seidel method, Newton-Raphson method, and Euler method, trapezoidal method, then Runge-Kutta method. So these methods are numerical methods to solve nonlinear problems. For example, Gauss-Seidel method and Newton-Raphson method are used to solve load flow analysis. So they are like iterative algorithms to solve nonlinear problems. Similarly, Euler method, trapezoidal method, and Runge-Kutta method, they are used to solve differential equations numerically. So what these softwares will do is that they represent the actual physical component as a mathematical equation and apply these numerical algorithms to solve those problems. So so that's how these softwares work. So this is just to give an overview of how things work in the industry. So I have provided here a screenshot from the PSSE software. So this is actually a IEEE 9 bus system. So basically what this system means is that it has 3 generators. This round shape represent generators, and this triangle shape represents the load, and these vertical lines represents the bus, and the horizontal lines represents the transmission line. So basically, and this particular symbol represents the transformers. So this is actually a 9-bus system. And by the way, the PSSE is a commercial software, mostly used in industry. But if students wanted to learn this software, you can always download a student version for free of cost. Only thing that you need is a student email ID from your education institution. So you can apply, go to the PSSE website and type in your student ID, and you can download a student version. It will not be a complete version, but you can definitely study these kind of scenarios. The maximum number of buses in a student version that you can use is 50. So what I'm trying to say here is, this particular system is a 9-bus system which has 3 generators, 3 loads, and a bunch of buses. So buses is actually common points or substations, we can say. So now if I wanted to, let's say I wanted to analyze how this network will behave when this particular generator trips. So I wanted to simulate this case. So how this software will do is that software will represent each components as a mathematical equation, and then it will solve those equations for each time steps. And let's say when I trip the generator, the power from this point will be 0, and accordingly the calculations will change, and finally it can produce a result. So now based on the results that we got, we can analyze how the system will behave in reality. So what's the intention of simulation is that we cannot conduct these kind of studies in an actual system. We cannot take out generator to study these. What industry people do is that they simulate the case and try to get an understanding of what will happen when this particular generator trips in reality. So we will get a sense how the actual system will work based on the results from the simulation. So that's why we are using simulation. And in electrical engineering and specifically in power systems, simulations is a big part of the job. Now, having said that, now I would like to demonstrate a small example how we can use these tools to solve a particular problem. So in this case, I have used a simple pendulum. So a simple pendulum is like a mass attached to a string, and it is connected to a point here. So actually the variable L represents the length of the string, and m is the mass of the ball, and here the variable alpha represents the angular displacement. So this is a simple pendulum setup. So what we are going to do here is now we are trying to solve this particular the dynamics of this particular simple pendulum. So the differential equation which represents the motion of a simple pendulum can be represented as this. So I think most of us have studied the simple pendulum during our higher secondary school. So I'm not going into the details of the derivation of this particular equation. Let's assume we have a differential equation that represents the dynamics of a simple pendulum. Now we would like to solve this particular case. So how we can solve that? So before going that, I would like to specify the variables here. So here g is the acceleration due to gravity, L is the length of the string, alpha is the angular displacement here, and what this equation is representing is that the second derivative of the angular displacement is angular acceleration. So the angular acceleration is proportional to the alpha sine of alpha and is multiplied by this constant. So here to solve this particular equation, we need to like decompose that into two first order equations. So how we can do that? So we know that rate of change of velocity is the acceleration, and rate of change of displacement is the velocity. So this particular term is the acceleration. So we can write it as rate of change of velocity. So rate of change of here omega represents the angular velocity. So rate of change of angular velocity, we can keep this term, and we can say that rate of change of angular displacement is the angular velocity. So basically we decompose these two equations here, and now we want to solve that. So so I have mentioned here that we have multiple methods available to solve these differential equations. The method that I'm going to demonstrate today is Euler method. So Euler method is the most simple method to solve differential equation. Uh, so what Euler method will like how we can solve is by using Euler method is like this. So basically these particular equations are expanded using a Taylor series, and we neglect the higher order terms. So what is happening here is that the uh, the d alpha by dt term, we represent it as alpha of t plus delta t, meaning that we are trying to find the value of alpha after a time step delta t, and it is we can represent this as a, we can represent the whole two equations in an algebraic form here. So now once we got these equations, it's quite straightforward to implement those in Python. I will just show that how to solve those equations here. So I have created a Python script to solve this particular simple pendulum problem. I'll just give an introduction to these things if anyone is not familiar with the Python. So here what I'm doing is I'm importing certain libraries from Python to solve these are predefined libraries, and we can make use of these libraries which are already being developed by some other people. So I think I will move quickly because I'm running out of time. So here I have defined a function called solve using Euler method. So if you check this particular equation here, it is actually alpha at a time t plus delta t is calculated based on its previous value and the previous angular velocity. So the same thing I have given here. So it's the alpha update means it's the alpha value at the next time step, and alpha 0 is the value of alpha at its previous time step, and this omega naught I have represented here. This is the omega naught I represent here, and time step is the delta t. Similarly for omega value here, omega I represented in a similar fashion. So omega update is omega naught minus g by L sine alpha, which is the acceleration due to gravity by length of pendulum by sine alpha, and times delta t, which is the time step. So we can simply write those equations here. This is basically the Euler method to solve a differential equation. And if we run this particular program, if nothing goes wrong, I think we can get some results. So here we can see that the red curve shows the angular displacement alpha, and the blue curve shows the angular velocity. So what I'm trying to say here is that all these softwares here, whatever the commercial software available in the industry are working on a similar principle. So they will represent all the physical components. So in this particular example, the physical component was a simple pendulum, and it is represented using a mathematical equation, which is a d square alpha by dt equation. So this physical component is represented as a mathematical equation, and mathematical equations are solved using numerical methods. So this is the basic way these softwares work. So if we have an understanding of this, then it will be really easy to work on this kind of softwares. Now, so Python is an important tool in the electrical, specifically in power system sector. So if you know Python, that will give you a leverage when you are applying for jobs, and that will move you ahead of the queue. So I would recommend students to learn Python. It would help you in the long run, definitely. And I would like to mention one more thing here. So instead of writing all these equation by ourselves, the numerical methods. All these numerical methods will already be inbuilt in Python, and we can directly call those stuff. That is what I did in figure 2. So if you check figure 2 and figure 1, both are same. One is by using Euler method that I developed, and one is by using the inbuilt library that Python provides. So we can make use of either of these two cases. Now, specifically, if you want to solve a power system problem, we can do that as well. So in this particular case, there is a single machine connected to an infinite bus. I'm not going to talk about all this stuff, but what I'm trying to say here is that if you want to solve any electrical system, you can definitely solve that using the Python version. So I have done that here in this particular program. It will take a while to solve. So so even if you don't have all the commercial software, or you can either apply for a student version and try to learn that, or you can develop your own script to solve this kind of problems. So I would recommend learning Python by doing some sort small stuff. And if anyone is not aware of Python, then I think that will help you guys in the long run. I think it's gonna take a while because it's a bit. Oh yeah, I think I got the results here. So what I did here is like in this particular system, it was operating. I keep the torque as 0.9 per unit, and at 15 seconds I drop the torque to 0.6 per unit. So this is the result that I got, and this is how the synchronous machine's angular frequency deviates when the torque is suddenly changed. So this kind of response is what we are studying in actual power system using the commercial software. So this is similar to an incident. Let's say I had a generator in the network, and one generator suddenly lost its let's say 30% of its actual capacity. So suddenly the frequency will deviate. So angular velocity is essentially the frequency of the system. So the frequency will drop, and it comes to a stable state finally. So if this drop is too significant, then system may not come to a stable steady state, and it will collapse. So these kind of studies is what power system engineers will do in their job on a daily basis. So I hope that this give you an understanding of how the jobs in power system will looks like, and what are the recent trends in power systems, and how you can improve your CV, and how you can apply for jobs, and what are the tools that you need to look for when applying for a job, how Python can be helpful. So I hope this was helpful. So if people have any questions, I'm happy to take that. Please don't hesitate. I encourage everyone to ask questions. And thanks for listening to this presentation.
Thank you, sir. And this is a time for some questions. And we have got some couple of questions. Sir, the first question is like, it's from Ragesh, sir, and it's like, will computer science and information technology BTech graduates can get a job in this industry?
Sorry, your voice is breaking down. Can you repeat the question, please?
It's like, will computer science and information technology BTech graduates can get a job in this industry?
Yeah, definitely. IT people are working in the industry that I'm working in. So basically, what they are doing is they are forecasting the trends. Like for example, the load and generation forecasting, and like the power system itself is a complicated system, and all the network and the software tools that we are using are highly there are like IT people, so many IT people working to make sure everything is working fine. So IT people have a lot of opportunities in the power system sector. Yeah, definitely, I would say yes. and in specifically in jobs, in terms of job, they can work as a network engineer, or they can work as a developer, and they can work as a machine learning engineer, and or a forecasting engineer. So different opportunities are there.
Thank you, sir. And the next question is like, is IES is hard to crack?
I personally haven't wrote IES, but I know like a couple of my seniors has got IES. So I don't know like if it's too hard to crack, but the exam is a bit challenging. I think it's 3 days exam. So probably you might need to prepare a bit more compared to the other exams. But I'm personally not aware of that, like how hard the exam will be. Um, yeah, but definitely you can get some of my friends already got into IES, so I think it's possible.
Thank you, sir. And the next question is like, is a diploma holder can enter into a job opportunity like this?
Yes, definitely, yes. So when I worked in Power Grid Corporations in the control room, one of my colleague he did diploma, and there are like bunch of other peoples as well who worked with me was a diploma holder. So definitely there is possibility, but I think but in terms of promotion, I think it will be a bit challenging if you are only having diploma. I think I would recommend you to take a better course. Once you get the job, you can do it parallelly, so that you will get promotions on the over the long term. It will be beneficial, I think.
Sir, the next question is that, is climate change possessing any new challenges or threats on power systems and its regulatory model?
Yes, definitely. So climate change, for example, you probably might be heard about the bushfires that happened in Australia like a couple of months back. So that's the main reason is climate change, and these bushfires created so many problems in the operation of the power system network here. So climate change is causing serious troubles, and also like the changes in weather and severe storm condition. For example, if we have like a lot of solar panels installed in the network and suddenly the weather change, then there will be like a huge drop in the active power generation from these plants, and that will affect the system. So climate change is definitely affecting the plan, and in terms of changing the what you call the criteria, different agencies, government agencies are taking into account of these factors, how we can reliably operate power systems during such events.
So next question is, if all the cars in the world become electric, where will be the electric power be generated?
So the electric power will be obviously generated if the present trend continues, then the power will be generated from solar farms and wind farms and from hydro plants and all. So if all the cars become electric cars, then the electric load on the system will be higher. So we need to have that much amount of additional generation in the network. Uh, so it depends, like, and it's not like an overnight change. It will occur gradually. So the network will adapt accordingly, I think. That's my personal opinion.
So next question, in your opinion, which are the more renewable power system options in Kerala?
I think based on the weather conditions, I think I'm not 100% sure, but I think we have wind farms in Idiki, and in the Kerala Tamil Nadu border we have multiple wind farms. In terms of solar, I think since we have a like long rainy season, I'm not 100% sure like if large scale solar farms will be feasible. But that is definitely an option for like rooftop solar PVs are getting increased like these days. So definitely rooftop PVs will be there, and wind farms I don't know. I don't know much about that.
Again, a question based on academics, whether an MTech graduate in power systems can do another MS in Australia.
Yeah, definitely. So I forgot to mention that in my presentation. So even the beta graduates can apply for PhD. So I personally know one guy. He did PhD straight after his bachelor's, but he's not from India. He was from Russia. But that's an option. But I don't know how to apply after the bachelor's. But MTech graduates can definitely do master's course here. Um, but it's not a big problem. I mean, it's definitely doable, and even the bachelor's students can also do masters here. But the only problem is it will be like a bit expensive here. So if you can afford the fees, then you can definitely go for it.
So next question is how much penetration of renewable energy can we have for a stable operation of power system?
Yeah, that's an interesting one. So there is no right or a predefined limit. Research are going on at the moment, but I think right now in Australia we have more than 25 or 25 percentage, and sometimes in some states, for example, in South Australia, the penetration goes beyond 50 percentage, and that is going serious. That is creating serious troubles. So anything beyond 50 at present the network is not capable to handle that. So that will cause serious troubles. But in future, if you have like a lot of batteries installed in the network, then we can handle more. But there is no specific limit uh, defined for that. It's still a research topic.
So next question is, will you please explain the courses applicable for a postgraduate of power systems apart from doing PhD in Australia?
Uh, Postgraduate courses, but like here most of the master's courses are not specific. So if you come to Australia for doing a master's course, it will be like Master of Electrical Engineering, and in that master's course you can specifically choose courses. So if you are interested in power system courses, then you can definitely opt for different power system courses once you get the admission. But there is no, like in India. In India, for example, we have, if you are doing a MTech course, you can do either control systems or power electronics or power systems. But here there is limited opportunity. So in masters, if you are applying for a master, you will be a Master of Electrical Engineering, and you can take specific courses by your own that are offered by the university.
Sir, next question is there any integrated course for both MTech and PhD? That is, we can combine the study of both MTech and PhD in Australia.
MTech and PhD, it's not like integrated courses, but I think once you finish the master's here, you can definitely apply for a PhD. Uh, and sometimes you can enroll as an MPhil student, which is Master of Philosophy. And once you finish that, which is, I think you can finish the MPhil in 1 year or 1.5 years, and then you can convert that to a PhD. I know one guy from India. He was initially doing MPhil and then converted his MPhil to PhD. So that's possible. But there is no integrated courses similar to the one in India. But I think the duration of the PhD is a little bit less here. For example, if you are doing a PhD in India, let's say you are doing it from IIT or IISc Bangalore, it will be a bit more time consuming. You will probably end up spending around 5 years to finish the PhD, 4 to 5 years. But on the other hand, here you can probably finish the PhD in 3.5 to 4 or maximum 4.5 years.
Sir, the next and the last question is that is there any startup options in this field?
Um, I don't know. Like obviously there are startup option in all fields, but I am not aware of any. But probably you can, if you are interested in doing a consultancy. It's not like a big startup, but you can be an independent consultant. You can do your own technical studies of system. I think in India, the importance of I mean, the renewable energy is getting bigger and bigger. So there will be a lot of opportunities popping up in the near future. So there will be like huge requirement for grid connection of power systems engineer. So you can obviously start a consultancy agency where you can recruit multiple engineers to do the studies, and that can be a viable option. Or otherwise, maybe, I don't know, like you can create an innovative technology, battery technology or something like that. I personally haven't tried anything, so I'm not an expert in that. Sorry about that.
Thank you, sir. And that's all about. I think no one is having any more questions. So we'll wrap up the section. And I sincerely thank, on behalf of Universal Engineering, I would like to express our profound gratitude to our speaker of this day, Dr. Vinay, and for his great and inspiring section. And I express our sincere thanks to our principal, Dr. Joske Jacob, and I would like to express our sincere gratitude to Ms. Remya VR, and also express a vote of thanks to all the staff members who have made the seminar a grand success. Once
Uh,
again, thank you everyone. We
Just
appreciate
one
your
more thing
effort.
before we wrap up. Sorry to interrupt you. Just one more thing I would like to
Yes,
add.
sir.
So if anyone have any questions, you can always email me. I will try to reply your questions. So this is my email ID. So if at all anyone have any further questions, I'm happy to answer that. And just shoot me an email in this one. Yep, that's it.
So all the attendees can take a note of his email ID, and if you have any doubts throughout the day, you can mail him. And once again, thank you everyone, and we appreciate your effort for being here. And I would like to request all to fill the attendance cum feedback form that we have sent in the chat box, and it will be available for 30 minutes. Thank you so much for joining us today. Stay safe and stay healthy.